Hi students, welcome to all of you to this concepts and snippet session. Today we are going to discuss chemical kinetics, a very interesting chapter in physical chemistry. As you know, thermodynamics deals with feasibility of a process or whether a process is spontaneous or not. Equilibrium deals with the extent of a reaction, how far a reaction will proceed, whereas chemical kinetics deals with the rate or speed of a reaction. Okay, so the scope of chemical kinetics is very wide because some reactions may be thermodynamically feasible, but kinetically they may be slow. So it is essential to know whether a reaction is slow or fast. So chemical kinetics deals with studying the speed or rate of reactions. Now, how to define the rate of a reaction? Rate of a reaction is defined as change in concentration of reactants or product in unit time. I repeat, rate of a reaction is defined as the change in concentration or change in molar concentration of reactants or product in unit time. That means the rate is expressed per minute or per second. In 1 minute or in 1 second, how much reactant is converted to product. Okay. So, in chemical kinetics, we use two types of rate. One is the average rate of a reaction. It is the rate of a reaction between two intervals of time. Say between time t1 second and t2 second. It is called the average rate. Whereas, we are more interested to know instantaneous rate of a reaction. It is the rate of a reaction at a particular instant of time. Okay. So, let us discuss first our rate of reactions. Then we will go to average rate and the instantaneous rate and how to express the rate. It is called rate expression. Remember, rate is expressed per mole per second or per minute, unit time. So, the change in molar concentration of reactants, change in molar concentration of reactants or products in unit time is called rate of a reaction. Rate of a reaction. In terms of reactant, you can say it is the decrease in concentration of reactant in unit time, or in terms of product, you can say increase in concentration of product in unit time. Now, what is average rate? What is average rate? It is represented as delta x by delta t, where delta x is the change in concentration of reactant or product in a time interval delta t. The interval is large. Okay. The rate of a reaction, measured between two intervals of time, is called average rate, So, delta x by delta t equal to minus of x2 minus x1 by t2 minus t1. Or what is it minus sign shows? It shows the rate is expressed in terms of decreasing concentration of reactant. Okay. The negative sign indicate the decreasing concentration of reactant. reactant, okay. X1 and X2 are the molar concentration of reactant, at time T1 and T2 second respectively. So you are measuring the rate between two intervals of time. As far as chemical kinetics is concerned, we are interested to know the instantaneous rate. It is the rate of a reaction at a small interval of time, dt, small dt. It is called the differential rate. So the instantaneous rate of a reaction, instantaneous rate of reaction. Instantaneous rate of reaction is expressed as dx by dt. It is the rate of a reaction. It is the rate of a reaction at a particular instant of time. Particular instant of time. So the change in concentration is very small and the time interval is also very small. Okay, dx by dt. It is called differential rate. Very important one, rate of a reaction is expressed per mole per unit time. For example, when A moles of A react with the B moles of B to form C moles of C and D moles of D, the instantaneous rate is given by dx by dt equal to, with respect to reactant, we will put a negative sign. For 1 mole, we take the reciprocal 1 by A into dA by dt, change in concentration of reactant A with the type. Or in terms of B, it is minus 1 by B dB by dt. Or equally in terms of product C, we will put a negative plus sign dC into 1 by C into dC by dt, or with respect to the product D with a plus sign 1 by D into dd by dt. This is called the rate expression. This is known as the rate expression. Okay. Now, what is the unit of rate? Rate is dx by dt. Therefore, unit is what? Mole per liter per minute or mole per liter per second. Okay. Unit of rate is mole liter raised to minus 1 second inverse or time inverse. Okay. Now, let us do a problem. What is the rate expression for the decomposition of nitrogen pentoxide to nitrogen tetroxide and oxygen? Remember, rate is expressed per mole. So, dx by dt, there is the rate equal to, with respect to reactant, we should put a negative sign, and per mole means you have to take the reciprocal of the coefficient. So, 1 by 2 dN2O5 by dt, or equal to, with respect to product, again per mole 1 by 2 dN2O4 by dt, or again with respect to oxygen, the product again, it is only 1 mole, so dO2 by dt. Okay. So, this is how we express the rate of a reaction in terms of decreasing concentration of reactant or in terms of increasing concentration of the product. Okay, we'll be doing more and more problems based on chemical kinetics in our next session. Thank you.